In 1961, Francis Crick and Sidney Brenner cracked the grammar of life without reading a single letter of it. By adding and deleting single letters from a virus's genes and watching it live or die, they proved the genetic code is read 3 letters at a time. By 1961, everyone agreed on the headline. The order of DNA's 4 letters somehow spells the order of a protein's 20 amino acids. But the grammar was a mystery. How many letters make a word? 2 give only 16 combinations, too few. 3 give 64, more than enough, perhaps too many. Were the words read overlapping or in clean separate blocks? Was there punctuation between them? Nobody knew. Crick saw a way in. Imagine the message as a sentence written without spaces, read from a fixed starting point in fixed-size chunks. Delete a single letter, and everything after it slides out of step. Pure gibberish. Could you use those shifts, adding and removing single letters, to count the letters in a word? They needed a gene that would shout when it broke. They chose the R2 region of a virus, the T4 bacteriophage, a gene so sensitive that a working copy let the virus grow on a certain strain of bacteria, and a broken copy simply couldn't. Life or death read straight off a dish. And they had the perfect tool, a chemical, proflavin, that adds or deletes single letters of DNA, never just swapping one. Here is the whole idea on a sentence you can read. The cat ate the rat. Take it 3 letters at a time, and every word lands. Now, delete 1 letter near the start. The reading frame shifts by 1, and from that point on, every word is scrambled. The message is destroyed. A single deletion, a dead gene. Call it a minus. Now the trick. Downstream of that deletion, add a letter back, a plus. Between the 2 changes, one short stretch stays garbled, but beyond the second one, the frame clicks back into register, and the words read true again. A plus and a minus near each other, and the broken gene often heals. So how many letters make a word? Watch what heals and what doesn't. 1 deletion, dead. 2 deletions, still dead. The frame is off by 2. But delete 3 letters of the same sign, and the frame shifts by a whole word and snaps back into step. The message downstream reads true again. 1 or 2 stay broken. 3 heal. And that is exactly what the dishes showed. A virus carrying 1 or 2 changes of the same sign stayed dead, no growth. 3 changes together, and the plaques came back. The virus lived. The gene could only be mended in steps of 3. The reasoning allowed 3, or any multiple of it, and 3 is the answer. From a virus living or dying, they had read off the architecture of the code without sequencing a thing. It is a triplet, read from a fixed start in clean, non-overlapping blocks with no commas between the words. And because 64 words spell only 20 amino acids, the code must be degenerate, several triplets sharing a single meaning. The shape of the code was fixed by pure genetics, while others were only beginning to read its very first words. That is the beauty of it. In 1961, no machine on Earth could read a single base. Yet by adding and subtracting letters and watching a virus grow, Crick and Brenner reasoned their way to the deep arithmetic of an unseeable molecule. 3. It is inference at its most daring, deducing the shape of the invisible from what it does. Life reads itself 3 letters at a time. Beautiful experiments.